We're looking at how to graph a quadratic equation where the quadratic or the function is written in this particular form. We have an example now, f of x equals x plus 3 squared plus 1. And this one's going to highlight a couple of different observations that we're going to see as we proceed. If you remember, we have some things that we want to look at. We can identify if the graph opens up or down, what its vertex is at, if it crosses the x-axis, where, and also the y-axis. So right now, we're going to find out if it opens up or down. And in order to do that, we need to look at this coefficient a in this particular function. And you see that the coefficient a spot is right there. It's an understood 1, which is a positive number. So I know that my graph is going to bow upwards. The second thing that we're going to look at is the HK coordinate, or the vertex. So I'm going to look at the particular situations and see what we have. Well, the K value is a 1. The H value, well, it's going to be a little tricky to see. It looks like it's a 3, but it has to be in the form of x minus an h. So it's not a 3, and actually I'm going to have to do a little bit of work. It's going to be an x minus a 3. What I have written here, x minus a minus 3 squared plus 1, is the same thing as x plus 3 squared plus 1. But I wanted to put it in the form of x minus the h. And now I can see that really the h is a negative 3 value. So now I have a vertex. The vertex of my graph is at the point negative 3 and 1. So I'm going to backwards 3, 1, 2, 3, and up a 1. So there's the vertex of my graph. The graph bows upwards. Now I want to look at what happens when my function equals 0, or what are my solutions, or where does it intercept the x-axis at? Well, you might be looking at it right now and thinking, well, Willie, didn't you just say the graph bows upwards, and that the vertex of the graph actually lies above the x-intercept or the x-axis? So it's not going to touch the x-axis. That's true. That's exactly true. And we can verify that algebraically as well, if we're not convinced. So let's take our function, x plus 3 squared plus 1, set it equal to 0, and let's solve this guy out. Subtract 1 from both sides, take the square root of both sides. Subtract 3 from both sides. And the square root of negative 1, we interpreted that as I. So I have I. So I have two solutions here. One solution is minus 3 plus I, and the other solution is minus 3 minus I. And you can see by this result here that I have some imaginary numbers, which means I don't have any real solutions to this particular quadratic. And that makes sense. We discovered earlier, since this graph bows upward and the vertex is above the x-axis, I'm kind of expecting no real solutions. And this is what this tells me. There are no real solutions. The next thing that we want to look at is what happens when we evaluate the function at 0, or f of 0. So this could be a 0 plus a 3 squared plus a 1, 3 squared, 9 plus 1 equals 10. So I have the function evaluated at 0, f of 0 equals 10, which gives me the point 0, 10. Remember, this value right here is my x value, and this 10, that's my result, or my y value. So I have the point 0 and 10, and that's also on my graph. So I'm going to go over 0 and up 10, and there I have some points on my graph. And now I can kind of sketch in everything else I know. I know that it goes to these points, and it bows upwards on this vertex. And I also know that parabolas are also symmetrical around this axis, this vertex axis. So there I have a rough description of what that graph looks like, or what that quadratic. I know for sure it goes to this point, the vertex, and it goes for sure through that point on the y-axis. and it's symmetric. So that's a very good representation of this particular graph.